Alright, I'm making this video to help us with solving systems of equations. Sometimes it's very easy when both equations are already in slope-intercept form. When both equations are already in slope-intercept form, you just simply need to put it in the calculator, and you need to the y1 and y2, make sure everything's correct. And then if you press graph, you probably want to make sure that they're not parallel, because remember, if they're parallel, then that means there's no solution. So it does cross. It looks like it crosses somewhere here. That might be like a -2 something. So now I'm going to press second graph and look at my table for a -2. Yes, and I was correct. The solution is at -2, 3, and I can see that because these two numbers right here are the same, so that tells me that the solution is the x, y. Then if I want to I don't want to spend too much time graphing it, but if you go -2, then up 3, I know they must cross here. So I know they have to cross at this point. So for this first equation, I know this is my y-intercept. So if I go up to, this is a y-intercept, which is -3, so 1, 2, 3. So I know this first line has to look something like that, because remember, both equations must pass through this point. That's why it's the solution. The second equation, the y-intercept is at +2, so then I know my second line has to look something like that. And if I press graph, once again, I can verify, yeah, it looks something like that. It doesn't have to be exactly perfect, but I do want to make sure the y-intercept is there for both of them and that solution point so I can graph. Now on the other side, what you'll notice is that both equations are not in slope-intercept form. I'm sorry, maybe, oh, this one actually is. So this one's already ready to go. It's this one that I need to get in slope-intercept form. So I need to go ahead and make sure I can just solve to get the y by itself. That has actually an invisible 1. So I'm doing the opposite of x, so I can move it over here. And there's no coefficient in front of y, so now I just have y equals 1 plus 1x. So now that I have this equation and this one's already ready, I can now do the same thing I did on the front, which is put one of the equations in the y1, one of the equations in the y1, the other equation in the y2. And remember, the first thing we usually, you should check, maybe get in a good habit of making sure that the lines are not parallel. Yes, they do cross. It looks like they cross maybe at 3, something. I don't know. So now I'm going to go to second graph and look at my table. I'm going to look at where I thought it was crossing. I thought it might have been a 3, but was it a 3? No, it's actually, this is where it's actually a 2, 3. And then I know my solution is at 2, 3. And now when I want to graph them, I can look back here. I know it should look something like this. The y-intercept is 1 for this one, so I know that one has to go like that, something like that. And the other one has a y-intercept of 2, so I know that one looks something like that. And yep, that's exactly what my graph looks like here. So that's what you're going to be doing for the whole worksheet. You will have about 12 minutes to do so. Thank you.